Okay, hello everyone. Interesting day, interesting weekend for me, an interesting day today with the AWS issue. Um, as I said, I was a little bit ill over the weekend, so my voice may crack as I'm dealing with this. I don't know. I don't know if it's a cold. I usually get October weather change. It's great weather too, can't complain. But I usually get a little bit of a bug. I'm usually pretty healthy, so all right, but I don't want to complain or anything. Welcome to week number 8. You're all hanging in there, and that's always a good thing. Let's get started. So we're going to go into more group functions, continuing a little bit where we left off last week. And it was a light week. It's not that much heavier this week, but I do want you to continue to understand these group functions. They're very useful in the whole SQL realms of relational databases. So here we go. For objectives, construct and execute SQL query using group by. These are the group by and having are the topics. Construct and execute a SQL query using group by and having, and you'll see why that's important. And construct and execute a group by on more than one column. And why do we need this? So what if you wanted to know the average salary of all employees? You would run a query that looks like this. Select, and that should be not age, but AVG. So that's the wrong function. I should have changed that. I have to make sure I change that. So we all know that average is not AGE, right? It's AG, AVG, excuse me. But what if you wanted to know the average salary of employees based on their department? So we would have to run essentially something like, and I don't know why I did that, something that looks like that. Oops. So because I want to make sure you all know what the function is, let me pause. And that's kind of a faux pas of mine. And take a look at actually running an average in developer. So let's take a look. So select, yep, we still want to run AVG salary from employees. Yes, it's AVG. We all know that, right? I just wanted to not confuse you. And there's our average. So ignore the slides. I'll definitely have to change that. So it's AVG. So if we wanted by departments, we'd probably have to do something like that. Every department and so on. But there's an easier way to do that. It's the group by function. So use the group by clause to divide rows into tables into smaller groups. The summary information about each group can be returned. So if we wanted to create a query that will divide our employees by department, excuse me, you see this query here, select department ID, round average, and that's just a function, a rounding function, average, and I actually did it right this time. Look at that. Average salary, and then we know that the round is rounding it to two decimal, right? 2 digits to right of the decimal. And then this whole group by is what will cause it to be grouped by the department ID. And remember, the order by just puts it in order, ascending. So this will give you average for department 10, 20, and so on. All right. Does that make sense to everyone? you can use that group by to differentiate between the departments in our little example here. Let me just check the attendance right quick. Oops. Calls here. 1 second. I don't want to leave anyone out. All right, so that's the group by with group functions. That makes a job like this so much easier. And I just went over that. So here's a challenge for you. What is it? Query to find the maximum salary of employees in each department. Well, it's another group by scenario, right? So you would construct it. Whoops, Diane, go ahead.
I had a quick question. So it's looking at all the it's finding the average of all the salaries and then it's just showing one entry for each department ID.
Yes, that's how that group by works. If you're going to use a group by each of these departments, it will separate the employees in that department and only average that department. So it's going to be one value for that department, right?
Yeah. I guess I was confused where if you did like select department ID and there were like multiple employees with department ID 10 and stuff, it wouldn't list multiple places like 10, 10, and have the same average.
No, because it's going to group all of the employees. That's what the group, that's a good question. All the employees in Department 10 are going to be in that group. So it's a subset of the employees. It'll group them for Department 10. So it's almost like it knows that if that department ID is 10, then
Mhm.
that's how it's going to group those employees.
Okay, that's interesting. Okay, good to know.
So yeah, so it's almost like running a distinct, but it will list. So it's a subset. So this is the subset of the employees. So yeah, so you won't see 210, but if there's two employees in there, um, and there's a way you can, if you wanted to count the number of employees and all that, you know how to do that. Uh, but if as long as you're using a group by this department ID, it will first list all the departments, even the one employee that's not tied to a department, and then average all the salaries of that based on your group function. Right. Good question though. Good. Very good. Right. So here's the answer to that. It's the same idea using a group function and the group function max, and then the group by department ID will do the same thing. And you notice here I left out the order by just to let you see that it is not in any order, basically. Um, and it's a system order. But anyway, you see the subtle difference by excluding the order by here. And so this is the max salary for all employees in each of these departments. And I think in our database, I don't think we have a lot of employees in each of these departments, but you can see how useful that is if you have if you have hundreds of employees and you need to group them by something like departments. Checking the attendance. All right, let's continue. All right, group functions require that any column listed in the select. Oh, here's one factor, and I'll go over the guidelines here in a bit. But when you're using group functions, any column listed in the select clause that is not a part of a group function must be listed in a group by if you use that group by clause. And it seems rather odd, but if, well, the way the system works, it reads, the way SQL works, it reads through all the columns in your select by, etc. And if you remember the order of things, well, not to confuse you, but just remember, and this will trip you up a lot, if a column is not a group function, then it has to be listed in a group by. So what's wrong with this query? Who can tell me what's the problem? If you ran this query, it'll produce an error based on what I just said. No one? Crickets. So based on this statement here, we're grouping by job ID. We're using a group function, average for salary, but last name has to be a part of your group by. It seems odd, but if you think about it, you want to also group by these two, parts of your database. If you did not, then it would be kind of maybe problematic if you want to list job ID and last name. So yes, you want to group by both. So that it should make sense, especially when you run it, and you're trying to get the average salaries of employees, et cetera. You do want, more information. So that's one of the reasons, kind of a common sense reason, but it is a logical reason or system reason within the database itself. All right. Excuse me, I'm gonna mute and blow my. All right, I'm back. I'm still alive, barely. All right. So you'll receive this error, not a group by expression, because of last name. And that's what that means. It's a kind of an odd rule, but if you really think about it, it should make sense. Yeah. All right. Count. Well, count is another group function, right? And this is just the example. We're going to look at how many countries are in a certain region. So we're going to group by that region, and we're just going to count the countries. Then you see here, group function count, and then region ID. So we can group by region ID, and this will tell us how many countries are in this region, 15, 20, and so on. Excuse me, you must remember that group functions nulls ignore nulls. Okay. Oh. Okay. Thanks, Diana. I didn't see your chat response till now. You're right. All right. Let's continue. So what am I? So count, just remember count can be used, probably the best way to use count in any scenario is use the wildcard. So you don't have to associate it with a particular column. So I'm just stating that this is probably a better way to ensure that that count is accurate, because of you could possibly run across a null and it would change your count. So whenever you want to count something specifically, use the count star, because this will count the number of columns. And even if it's a null, it'll still count because you may want to consider that. Yeah. All right. So can we filter using a group function, or essentially, can we use a where clause? Excuse me. So select department ID, max salary from employees where last name is not equal to King. So we're just excluding Mr. King, the CEO, from this query. Well, we can use the where clause is used to exclude rows, right? Before remaining rows are grouped together. So basically, we can exclude King and still come up with a valid average. Just using the where clause as another way to filter out results. All right, let's just look at a few more examples. So I want to show the average population of all countries in each region. round the average to a whole number. Here we go. Select region ID, round average population from WF country, group by regions, order by regions. So once again, it's just rounding to the whole number, the regions. So you're grouping by the regions. So an average population in that regions for basically for each country. Count the number of spoken languages for all countries. So count function, language ID, etc. Just remember, these are all, whenever you use a group by, be careful which column. If it's not a part of a group function, then it has to be included. Basically, you should use your common sense. What do you want to see and how do you want to group it? And then you'll be pretty good. Diane, go ahead. Diana.
Oh yeah. So I was wondering on that first example, well, you said group by ignores nulls, right?
Way back here, right?
Um,
Where was it?
it was actually the next one. Yeah, this one where this slide where number 8, row 8 says null, and I know our table just has one row without a department ID, but if there were multiple, since it ignores nulls, would it just list the next row would be like 9 null and then just another like salary?
Yes.
Okay.
Although that one is another, you have to be very careful about that. Because if the department ID is null, but there's a salary associated with it, yes, it would list that as number 9, but you would not know unless you added something like, well, yeah, add more information. But yes, that's what will occur.
Okay. Okay. Thanks.
Yeah, no problem. All right, we'll get to those examples. All right, some guidelines for group by. So it is important to remember if you include a group function, which you have these 7 or 6, excuse me, in a select clause, along with any other individual columns, each individual column must appear in a group by clause. That is probably the most stringent rule. And you really just legitimately need to think about what are you trying to accomplish with your result. Do you need other columns to identify? But just remember, if you include those columns in your select statement, or select clause, they must be in a group by. If they're not a part of a group function, that's the key here. You cannot use column aliases in the group by clause. Basically, it has to be the column name. The where clause excludes rows before they're divided into groups. So remember, they exclude rows before. So essentially, the where clause appears before you group, if you want to do it that way. We're going to create a sub of a subset. Right. Those 3 guidelines are pretty probably the ones that will give you the most issues, but if you remember these, you shouldn't have any issues. All right, moving on, we have what we call groups within groups. So groups within groups, what is that? So sometimes your group needs to be divided into smaller groups. Yeah, group within a group. For example, you may want to group all employees by department. Then within each department, you want to group them by job. That's a group within a group. And this example shows that. So select department ID, job ID, and we're going to count just the number of rows returned from employees. Where department ID is greater than 40, then your where clause and group by department ID, job ID. And remember, we're not using either of those columns in our group function, which is count. So you see it's department ID and department ID 80, we have 2 sales reps, and department ID 90, we have 2 ADVPs, and so on. So that's just showing you how many employees are in those employees of those job ID types are in those departments. So that's a group of a group. Does that make sense to everyone? You can read through that query and understand the results and what you're looking for. Okay. All right, cool. All right, there's such a thing as, excuse me, nesting group functions. Group functions can be nested to a depth of 2 when group by is used. So remember that if you go beyond 2, then you not only do you run into some confusion, but the system will give you an error. So round, max, average. So max and average, that's nesting 2. So the question here is how many values will be returned by this query? How many values? Round, max, average. So the max average salary from employees. What do you think? How many values? 1, more than 1, 20? Anyone going to take a chance at guessing how many values? Well, I say only 1. And if you run this query, of course, I can give you a chance to run it. Yes, so it's rounding the max average for the departments. So yeah, the max average. Now, would you need that? Or does that even make sense? And so if you average all the departments' salaries, the maximum is going to be 19,333 for each department. Kind of confusing, but should make some sense. All right. Yep. All right, the having clause. You're probably wondering, how does this use in a grouping function? So suppose we want to find the maximum salary in each department, but only of those departments which have more than 1 employee. So can we do it this way? Select department ID max salary from employees where count. Well, once again, if we remember way back in our group functions, we can't add group functions to the where clause, can we? So this one would produce an error. The group function is not allowed in the where clause. You can add conditions in the where clause like normal, but not a group function type condition like this one. And basically, you're counting the number of employees in the department, but this is where the having comes in. In the same way the where clause is used to restrict rows selected, the having clause is used to restrict groups. So in a query using a group by and a having clause, the rows are first grouped, and then group functions are applied, and then only those matching the having clause are displayed. That's a mouthful. So instead of using the where clause here, we can use a group function in the having clause. So we can rewrite that query, select department ID max salary from employees, group by department ID, having count, number of employees in the department greater than 1. So you see here that those are the departments that have employees greater than 1, and that's the max salary of those employees in that department. Okay. Does that make sense? Make sure you read through the query and understand how that works. And also understand the order of this query, select from, group by, having, order by. Remember, order by, I don't know if I refer to this, order by is always the last thing in your query when it comes to the flow. All right, here's a second example. Select region ID, round average population from WF countries, group by region ID, having a minimum population of greater than 300,000. So greater than 300,000, and this is the average population for the region. Okay. Let's group first by regions, and then the having clause is measured and, well, is filtered, is used to filter only for those regions that have more than 300,000 as far as the population. All right. Although the having clause can precede the group by clause in the select statement, it is recommended that you place each clause in the order shown. So yes, it is recommended. You can have it before, but please get used to putting this order, select from, where, group by, having, order by. And then within the select, you can have group functions. Remember, you cannot have group functions in your where clause. And then from is the table. This is the order that is recommended highly. And yes, this is where I was going to mention the order by. Order by is always last. All right, that was quite a bit to cover in our grouping functions and having, so group by, having. Two very useful. And yes, you will get a chance to practice on this. All right, we're going to shift a little bit. These are kind of a part of group functions. Hold on just a second. Someone sent me a message. Okay. So we're going to talk about roll-up and cube operations in grouping sets. Yeah, roll-up. Roll up your sleeves. All right, use roll-up to produce our objectives, to produce subtotal values. Use cube to produce cross-tabulation values. Use grouping sets to produce a single result set. These are fairly good in accounting and statisticians and all that. Use grouping functions to identify the extra row values created by either a roll-up or a cube operation. And probably doesn't make a whole lot of sense now, but you'll see why. So what if once we have selected our groups and computed the aggregates or whatever we're putting together across these groups, we also want subtotals per group and grand total of all the rows selected, like a spreadsheet. We could import the results into a spreadsheet application like Excel, get out our calculator, although you don't really need to get out your calculator anymore. If you know anything about Excel functions, you can probably take care of this even quicker. But as a matter of fact, you'll see here, this is not necessarily the best thing to do when you're looking at subtotals and grand totals, unless you have a pretty substantially large database, but it is good to know. So we could use some of the extensions to the group by function clause, and that's roll up, cube, and grouping sets. These are an extension, or the extensions to the group by. And you can use these extensions. Using these extensions requires less work, possibly, while being efficient from a point of a database. I may agree or disagree with that. It really depends upon what you're trying to do, and you'll see in a minute what I'm referring to. So roll up. In group by queries, you're often required to produce subtotals. This is the key here. And totals. The roll up operation can do that. Without using the roll up operation, the requirement would mean writing several queries and entering the results, for instance, basically creating a spreadsheet. So this is the Oracle's way of saying, well, we can do that for you. Watch what we can do with Oracle SQL. So roll up creates subtotals that roll up from the most detailed level to the grand total. So you're probably wondering where did they get this term from? Right. Any of you know about accounting, which I do not, but this comes from that verbiage, roll up, and yeah. So this is why Oracle SQL decided to do it that way. So the action is pretty straightforward. It creates subtotals that roll up to a grand total. Roll up uses an ordered list of grouping columns in its argument list. First, it calculates the standard aggregate, basically the standard group values specified. Next, it creates a progressively higher level subtotals, moving from right to left, through the list of grouping columns. Finally, it creates a grand total. So let's take a look at this query. Please absorb this, select department ID, job ID, sum salary, a group function here, from employees, where department ID is less than 50, so we're getting basically all the departments, 20 and 10, group by roll up. Remember, it's an extension of group by. Department ID, job ID. Remember, if you use the group by, same guideline, it's not part of a grouping function, then it has to be listed. And you notice here, it's a little confusing, but if you see here, our grand total is a 23,400. Our subtotal for group or department ID 20 is 1,900. Our subtotal for department ID 10 is 4,400. You see that we only have one employee in 10 and two in department 20. So subtotal, the subtotals are in that first red block. The grand total is in the last. So if you're aware of what to expect, you can see how that can be useful. So this is, this is a roll up or a roll down, but it's a roll up. All right. Does that make sense to everyone? Can everyone read through that query and see the results and maybe even see the usefulness of this? Thumbs up, thumbs down, thumbs sideways. What do y'all think? Can this be useful? I got one thumbs up. Everyone else is like, I don't know. I don't know what I'd do with that. All right. There's a formula for the result, for the roll-up result set. The number of columns or expressions that appear in the roll-up argument list determines the number of groupings. So the formula is the number of columns plus one. And if you think about it, it makes sense. You have a grand total, so the plus one, where the number of columns is the number of columns listed in the roll-up argument list. That's what you'll see as far as the result. So the number of columns in this query, there are two columns. In the example, two columns are listed in a roll-up argument. Two, right? 1, 2. And therefore, 3 values generated automatically. Right? 1, 2, 3, 1,300, 4,400, or 13, where am I? Oh, 4,400, 1,900, and 23, 4,400, 19,000 and 23,400. So that's how you would determine two columns, and there's going to be 3 results, two subtotals and a grand total, right? That's what it means. That could be a little confusing, but that's what we're trying to accomplish here. And basically, you see this null here, that's your roll-up column. And that's essentially representing the totals, whether it's a subtotal or the grand total. I know, pretty crazy. So without the roll-up, a group by is used without roll-up. What would the results look like? So without the roll-up, you just have results that look like this, which is what you would expect. You just get the sum for each of basically each of the job IDs, right, in the department. I don't know, with this simple database, probably that would be enough. So we're saying that multiple queries would need to be executed to get the subtotals. So that's the whole idea of the rollup. Get that subtotal and a grand total and only through one query. Now the cube is another extension of the group by clause. It produces a cross tabulation report. And yes, once again, accounting and spreadsheets and all that. If you're really into all that, this is for you. I am not, so I will frankly say that, but it can be useful to illustrate certain data points or information. So it can be applied to all aggregate functions like average, sum, min, max, and count. Column lists and a group by clause are cross-referenced to create a superset of groups. So the aggregate function or the collection of functions specified in the select list are applied to this group to create a summary of values for the additional super aggregate rows. So I know that really doesn't make sense. So every possible combination of rows is aggregated by a cube. If you this really gets deep into accounting, but you really need to understand how this is formed, and you'll see when I get to the example. So if you have n columns in a group by clause, there will be 2n possible super aggregate combinations. So mathematically, these combinations form an n-dimensional cube, which is why it's called a cube. So cube is often used in queries that use columns from separate tables, like what Amazon does with some of their supersets and tons of data. So companies like this will request cross tabulations because they have several reports called several databases called several. Yeah, it gets very complicated. So let's take a look at our example before, see if you get form some intuition on how this works. I will tell you, I mean, it will be very confusing to decipher this as far as a SQL query, unless you're a deep level accountant or it's someone who knows about cross tabulation and spreadsheets. All right, so here, select department ID, just same query from employees, where department ID is less than 50, same query, group by cube, and then the same, remember it is a group function, so we have the same results. So you have your total, still 22,400. You have your subtotal for this particular job ID, your subtotal for this job ID, your subtotal for this job ID. So that should equal 23,400. And then you have your subtotal for the departments, just like you had before. So it creates a cross tabulation. So you have all of these supersets in case you need to desegregate or differentiate between departments and employees all in the same kind of visual representation. You're probably asking yourself, why do we need that? Well, this is what accountants live for. Cross tabulation, they can see everything in one representation. And yes, you can do that with SQL and the cube, the group by extension cube function. Now, did I lose someone? I think I drove someone away, like I've had enough. All right, so that's cube. We're not going to dig into that too much. Just know that that's another extension of group by, and yes, I would run a few of the queries. I see if you can get a better intuition and understanding of that. I'm not going to go into that in too much detail. In my experience as a database administrator, I've never used either of these grouping functions. I've never used it in group sets. But it's something that Oracle would like for you to learn. So we are going to cover it. Okay, grouping sets. Grouping sets is still another extension of group by. So this is used to specify multiple groupings of data. Yes, I'm going to confuse you even more. Like you're probably saying, haven't we had enough of this group by stuff? Well, this one has some usages. So if you want to see data from employee table group by department ID, job ID, and manager ID, but also group by department ID and manager ID. Excuse me. So you want to differentiate here and group by job ID and manager ID. So when you have three different grouping sets, then you would normally have to write three different select statements with only difference between them is the group by clause. So we have three different sets of what we want to group by. So we can use grouping sets to do this. So we don't want to write more queries than we need to. So this is the whole idea where grouping sets came from. So take a look at this Interesting query. We're gonna run the same query, but we're gonna add department. We're gonna add, manager ID to our little sub salary. And we're gonna create 3 different grouping sets. Job ID, manager ID, department ID, job ID, and then department ID, manager ID. Once again, it's just a way to group all of this information, the same information that we had before, in a way that we can see the relationship between each of these grouping sets. Pardon me again while I take care of my sinuses. I know I should have a cup of tea or something. But we'll get through this. All right. So creating grouping sets, and you see the syntax here. The grouping sets is all enclosed in parentheses, and each of the grouping sets is separated by a comma. And the grouping sets themselves are in parentheses and separated by a comma, and it gives you this set. Manager ID, department ID, and job ID, and manager ID. And you notice that each of these produces the same total, right? So it's just that for some reason you need to group this in several sets so that you can evaluate, supposedly. All right. All right, so it's kind of a summary in these grouping functions. When you use rollup or cube to create reports, you quite often need to determine which rows in the output are actual rows returned and which are computed. The grouping function handles these problems using a single column from the query as an argument. Grouping functions will return a 1 or a computed row and a 0 for a return row. So basically, if you want to essentially see which rows are going to create basically a calculated result, and which rows are coming from the actual select statement, you can use this syntax. Now, I'm going to let you experiment with that. We are not going to go into that much detail on the midterm or even the final, but these are useful, especially when doing any type of accounting with large databases. All right, yeah, I know that was a joy. I know you're all so thrilled that you can dive right into that. I'm kind of glad we got through it. So our group by extensions, cube, roll up, grouping set, and then the grouping function. All right, and to try and confuse you even more, no, hopefully less, we're going to move from grouping functions into set operators, which is a little bit different, but it's, is it a part of grouping? Well, you'll see. You get to make your own determination. So our objectives here: define and explain the purpose of set operators. Use a set operator to combine multiple. Well, these are kind of like groupings, and you'll see what I mean here in a second. Which is why we put that in this particular module and chapter. So these are set operators. So I'm repeating myself. So they're used to combine multiple queries into a single query and control the order of rows returned. You can control the order of rows returned in a set operator. So why do we need to know this? Set operators are used to combine. I just said that. So sometimes you do need a single output from more than one table without doing a join. If you just want to combine. So this is where set operator comes in. It can return rows found in multiple select statements, the rows that are in one table, and not the other table. Jeez. All right, I will get through this. So let's set the stage here. Suppose we have these two sets of data. treat them kind of like tables. Our A table has the values 1, 2, 3, 4, 5. Our B table has the values 4, 5, 6, 7, 8. So we're kind of setting the stage here. So we're going to call our A table, these are our AIDs, whether they're common or not, but this is what we have listed. So before we get into defining what we're going to do with these two tables, let's cover some rules you need to remember. The number of columns of the data and the data types of the columns must be identical in all the select statements used in the query. The names of the columns, they don't have to be identical. They're just the number and the data type. Remember that. Column names in the output are taken from the column names of the first select statement. Okay. So any column aliases should be entered in the first statement as you would want to see them in the finished report. Okay. All right, continuing to set the stage here. Our first set operator is union. The union operator returns all rows from both tables after eliminating duplicates. So in our little two-table example, 1, 2, 3, 4, 5, and 4, 5, 6, 7, 8, our duplicates will be 4 and 5. I know that's a little hard to see, but it's like the intersection. And this is the syntax. These are our tables. AID is our column. We have our first table. Union is a keyword for your set operator. And so the result would look, so the result would just list the eight numbers without any duplicates. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And if you join A and B, you would get only 4 and 5, and that's would be your inner join. But a union will return all the values in both tables. Okay, does that make sense? All right. I promise I'm not going to die. I don't know if my voice is going to make it, but we'll charge ahead. Okay, that's a union. All right. Now, union all, that's union, and now union all returns all rows from both tables. And it doesn't eliminate duplicates. And the keyword here is just union all. So if you can do a union all with this query, you'll see result 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. So it returns all the rows from both tables. Union all. And then intersect is like a join, like an inner join. It only returns the common values from each table. So if you run an intersect, as far as a set operator, and it's the keyword intersect, you would get, in our little example here, you only get result 4, 5. And those are your set operators: union, union all, and intersect. And then minus, oh, I forgot about this one. Oops, can't forget minus. Minus operator returns all rows from one table, but not the other. So if we use minus A minus B, basically it will eliminate both everything in the B table plus anything they have in common. So our result would be just 1, 2, 3, because that's the only values that are singular for this or associated with this table only. And if you reverse that and say B minus A, you would get 6, 7, 8. Okay. So there's 4 set operators, and I'm going to go through some examples, but union, union all, intersect, and minus. So for some more realistic examples, after setting the stage, so sometimes you're selecting rows from a table that do not have columns, in common, you may have to create your own, and this is usually the case. And the easiest way to do this is just to include one or more null values in the select list so that you're creating your own. And I'll show you how that works here in a second. So remember to give one a suitable alias and a matching data type. For example, the employee tables contain a hire date, employee ID, and job ID. The job history table contains employee ID, job ID, but does not have a hire date. So what we want to do, if we wanted to union these tables, we have employee ID and job ID in common, but job history does not have a start date. So when we do something like this, you can use the toChar null function to create matching columns like it's shown here. So please read through this query. It's a union query because we want all the data from the employees and job history. So hire date, employee ID, and you have to have matching columns, remember. Employee ID, job ID from employees unions, and then the select to date, you're just creating a ghost column using nulls, and yes, it just fills it with nulls, right? And it continues to add all the information from both tables. All right, does that example make sense to everyone? Great. All right. So the keyword null can be used to match columns. So we just saw that. And then the data type, remember, toChar, toDate, toNumber function can be used to achieve this, this result. And hopefully you remember how to do that. So set operations and order by. If you want to control the order of the return rows in a set operation, you can use an order by. So you simply remember it's always the last thing that will show in your query, even in a set operation query. So if we use this example before, and then include an order by, remember order by, assuming we'll put nulls. Let's read this query so we understand results. We're going to order by employee ID. So that null column, let's look at the results. So it's basically going to order. Doesn't really matter what's happening here. It's going to order, right, by the employee ID. So it starts with a 100 and goes to 176. And hopefully you can see these duplicate values is basically how this employee went from accounting manager and so on. That's because we're combining the job history table with the employees table. So basically we're trying to ascertain who's had how many jobs and what have been those jobs and where were their hire dates. Some have hire dates, some were just, yeah. You may want to produce a report like this for some particular reason. Now, does that query make sense? Query and result make sense to everyone? Showing the query again and then result. The only difference here is that we're using order by to organize it. So we can improve the readability of the output by including the start date and end date in the job history so that we kind of know when that employee ended a job and started a new job. So now we're just including end date, right? Start date, end date. And we're including that in our job history table. And we have that in our employees table as well, so we can do that. So now this big mess, you can see that The president was hired on 87, right? And so on. VP 89, but change jobs. It's a little confusing, but the readability is there. If you follow the number of jobs the employee has had and when they were hired and when they, acquired a new job. And there's a lot of employees that are in the same job. Maybe not today, but anyway. All right. So the key or the set operators, there's 4 types. So intersect, minus, and then union and union all, and then to char. Remember, you can use any of these data functions to match the data type, and that is important. Whether you use to char or to number, you need to make sure the data type matches on those columns. All right. So that's our lecture material. Then we cover our requirements for this week. Where is Canvas? Canvas is back up and working. Okay. And I do want to remind you of something that you probably don't want to hear, but all right. Group functions part 2. Before I go into that, remember our next week, basically, you're going to be prepping for the midterm. And I'm going to cover all this on Monday. Basically, Monday is midterm Monday as far as the lecture material. So don't panic. I'm going to guide you as much as possible. Reminder, the midterm will be open from Thursday, October 30th. So you want to get it done Thursday so it doesn't interfere with your Halloween. Or you can get it done afterwards. And it will close Sunday, November 2nd at midnight. That's the midterm next week. Midterm. And it covers the first 8 modules. And yes, there's a midterm guide. And I will cover that on Monday. So once again, next week is midterm Monday. And hopefully I'll be very healthy by then. But let's go through our requirements for Module 8. Group functions, our lecture recording and lecture will be there. Good videos. I definitely recommend the set operators if you really want to dig into that. But the grouping functions, additional resources, all right, and some additional resources. Other YouTube videos. This one's on some of the set operators. There's some examples that they run through, usually pretty straightforward. So if you're still confused about all of this, please, especially the roll up and cube. I know you're just dying to look at the videos on that, but and then there's a document on that as well. But resources. Okay, and then our practice queries cover all 3 subject areas or topic areas in the module. The group by functions, the set operators, and the group by extensions. Bunches and bunches of many practice queries. Even some, if you want to practice some DDL, changing your table a little bit, that is okay. I definitely recommend that if you want to see how these particular queries work. There's a ton of them, lots and lots of practice. And then we have our normal, oops, I skipped over one. Oh, I didn't. Oh, I have to check that. Well, for 8.1, you just get the solutions only. which I may end up doing that in the future. Just have you go, I don't know, what do you think? Should I just give you problems and solutions or just solutions? I don't know. How many of you go through the problems and solve them before you view the solutions? Just a rhetorical question. Anyway, oh, it's just out of order. So it is. I have to switch the order of those. I'll do that after I leave. But practice and solutions, you have 3 sets of those. Practice and solutions. It is recommended, once again, to go through those. They will definitely help. They will definitely help in the assignment and truly will help with the midterm. I will tell you all now, every single question in the midterm comes from both the practices and the assignments. So if you want to get a heads up on that, yes, I would definitely. Yes, go through the practice and the solutions. All right. And then once you've navigated through all that, we do have one assignment as usual. And please remember to work through your queries, work through your solutions, run them in the developer, copy or paste your results, etc. We've all mostly have been doing a really good job with that. And so we have all the topics grouping having roll-up cube and set operators. So that should not be only 6 questions there. And then yes, you do have your quiz on the 3 topics. Yeah, see, it's a pretty much another light week. And I did want to make it, or at least the end of mid-semester, not too bad. And then that's all you need to do for this week. But please remember, before I let you go, make sure you finish that. Make sure you, if you want, because even though the midterm is lockdown browser, and I'll talk about this in more detail, I would definitely have notes or something you can use to reference for the midterm. And I'll talk about what's consistent in the midterm. You do have a practice, and we're going to walk through that. The testing responders lockdown browser, where you can, unless you're an overachiever, you can download it. But once again, we're in module 8. Make sure to get through those. And look forward to moving past that onto bigger and better things in module 9 and beyond. Okay, so let me stop my share. Bring it back over. So that's it for this evening. I still need to recover. But any last minute questions before I let you go? All right, not hearing. So please enjoy the rest of your evening. Enjoy this great weather, and I will see you all next Monday.
Thank you. Get better.
I will. Thanks, Diana. Bye, everyone.